Good morning. Yeah. All right. Welcome, everyone, here at this incredible mining facility in Georgia, and everyone tuning in with Bitcoin Magazine to the very first glimpse at Proto. My name is Max Guys. I lead product managers and chip designers working on Proto and other Bitcoin initiatives at Block, and I'm going to be your host for this morning. To kick things off, I'd like to introduce Thomas Templeton, who leads Block's hardware organization, as well as a number of Bitcoin initiatives. Thomas has played a key role in virtually every hardware product Block has ever shipped, starting with the earliest Square readers to Square Register and Terminal to BitKey, and of course, now Proto. Prior to Block, Thomas worked on the iPhone engineering team and held roles at leading semiconductor companies. Please join me in welcoming Thomas.
Right, thanks, Max. Welcome, everyone. Before we get started, I want to give a special thank you to Core Scientific for letting us use this facility today. For the last several years, mining hardware has become an area of increasing centralization for a network that requires decentralization to work. And that's why what we're here to share today is so important. I'm super excited to introduce Proto. Proto is a new part of Block focused on Bitcoin mining products aimed at decentralizing mining hardware and providing access to more tools for more builders, with the ultimate goal to help increase the resiliency of the network. Since 2009, the team behind Proto has shipped tens of millions of devices for Square and Cash App and BitKey. Our team of in-house chip designers, hardware engineers, software engineers, and operation folks bring combined decades of experience building category-defining products. And prior to Block, the team played key roles in flagship products for household names like Apple and Google and Tesla. This is the right team with the right focus and experience to build a better future for Bitcoin mining. So what have we been up to? At Proto, we do product development similar to how we do it at Square and Cash App, and that starts with listening to the customers. We met with hundreds of miners across dozens of sites, from large sites out in West Texas to small off-grid sites in East Africa, really to get the clearest picture of all that is right and wrong about mining hardware today. We met with mining leadership. We sat alongside repair techs and took apart countless machines, getting down to the component level to understand what fails and why. We met with finance folks and went deep into models to understand, beyond the headline spec, what are all the ways that impact profitability. We met with fleet managers to better understand what goes into their day-to-day, all to get a better picture of what's wrong with the industry. And we learned a ton. And I want to share three of them today. The first one is infrastructure is not optimized. The second is that things break a lot. And the third is software is a challenge. Now we're talking about each one of these in a bit more detail. The first is machines today are not built for Bitcoin mining infrastructure. And as a result, a lot of miners are forced to leave power stranded at the wall. And when it does come time to upgrade, the process is expensive, time-consuming, cumbersome, and just wasteful. Upgrading a new fleet is a lot like starting over, which requires labor and downtime, which means leaving money on the table. And those same machines are simply not built to last. And when they break, repair is a pain. It's not uncommon to have spare parts being scarce. You often have to take these big, heavy machines off a rack and take them to a new location to get repaired. And then when you do the repair, it's not made to be simple or fast, which means more downtime and leaving money on the table. And third, from a software perspective, there's no good way to manage everything. Across the dozens of sites we visited, I don't think we saw the same setup twice. Instead of something that makes operations more efficient, software was oftentimes more complicated and missing key pieces of data to be able to effectively run your fleet, which again, leaves money on the table. Now, none of these problems are new, but they've largely fallen on deaf ears for years until now. Meet Proto Rig. Proto Rig is an entirely new mining system. It's not just a new machine or a new chip, but a true paradigm shift. A shift away from disposable, single-use hardware to hardware that is durable, repairable, and upgradable. Rig is built to last, repair easily, upgrade in place, and make the most use of your facility. The first thing you likely notice about Rig is that it looks different. And that's because it is different. You know, a lot of things change when you stop thinking about hardware as disposable and you start thinking about it as long-term infrastructure. When you go back to first principles, you ask questions like, what makes a miner a miner? And in reality, it's just the hash boards. Everything else is infrastructure. And so with Rig, we made those hash boards easy to access, easy to swap in and out, easy to upgrade, and easy to add or remove based on your power needs. We've also made the whole thing more durable with better quality components, which means more uptime. And if those components ever do fail, repair is dead simple. Now, I'll talk about repair in a second, but first I want to talk a little bit about Mac. Today, miners have to deal with the design limitations of one-size-fits-all hardware. You fit what you can in the space that you have, and your hash rate is limited by your rack space. Rig is meant to solve this. In the space of 2 legacy shoebox-style machines, we fit 3 machines worth of boards, giving you 1.5 times the power per linear foot of anything on the market today. And when it's time to upgrade, this is where we really see the difference a form factor can make. Instead of ripping out and replacing entire machines every couple of years, all you have to do is swap out the hash boards. It's as easy as loading a dishwasher. And these hash boards, these new improved hash boards, will be backwards compatible with older hash boards. And they'll be able to sit side by side in the same machine, which means when you upgrade, all you have to do is pay for what you can actually use. And your upgrade plan can be on your own terms. And while you're upgrading these new hash boards, you can just keep mining. You don't need to power down large portions of your fleet. A 3 to 5 year asset now looks like a 10-year asset, one that gets both cheaper and more powerful over time. Because you're only paying for the hash boards to upgrade, you save 20% each upgrade cycle. And that doesn't factor in all of the hidden costs of shipping and logistics and downtime and labor and dealing with all the waste that you're throwing away. This is better for your books in terms of working capital, asset depreciation schedule, and most importantly, time to profitability. Now let's move on to other ways that our design impacts your earnings. Now, we all know that the best repair is no repair at all. But at Block, we really know this. Square hardware is built to take a beating, to be dropped on the floor, to be spilled on, to live up to all the things that bars and restaurants can throw their way every day and just keep working. Because the seller can't stop taking payments in the middle of rush hour because their hardware fails. And with Rig, even though it's likely going to sit on a rack and not move the entire time, we've designed it with the same high standards of both durability and reliability. And if something does break, repairs are as simple as the upgrade process. Today, with single-use machines, when a hash board breaks or a control board fails or a 90-cent fan stops working, it means downtime. It can take minutes or hours or even days if you have to send it out. With Rig, if a fan breaks, you just pop it off and put a new one on right there in place, right on the rack. No complex cable routing, no screws, no tools needed at all. You can do it with your bare hands. And if a hash board goes down, your machine doesn't stop running. It keeps hashing. And you can swap out a faulty hash board in literally seconds. Repair-related downtime all but goes away. Now, we'll have some hands-on demonstrations of just how easy it is to swap out components in a second. But first, I want to talk a bit about software. At its core, Block is just as much a software company as it is a hardware company, with thousands of designers and engineers building elegant, intuitive applications for our suite of products, from Square to Cash App to Tidal to BitKey, and now Proto. Proto Fleet brings together everything a miner needs from a piece of software, from power scaling to individual miner diagnostics to maintenance to overall fleet performance, all in one place. This can be an important part of streamlining operations, maximizing miner uptime, and minimizing time spent troubleshooting. Our software will be fully open source, both so you can verify what you're running and so builders can make it their own. We'll have options for running the software on-prem or in the cloud. And it'll work with Rig, of course, but it'll work with all the leading miners out there. And lastly, we're making this software completely free for anyone to use. This is a big part of our effort to decentralize mining, is making tools available regardless of your size, if you're running 5 miners or 5,000. OK, I've covered a lot, and I'm sure you're all excited to see this running. But I just want to leave you with this. Rig is mining hardware as it's meant to be. It's efficient in every way, from chip to repair time, upgrades to uptime, setup to software. And it gets cheaper and more powerful with every upgrade cycle. It has the fewest fans, the fewest cables, the fewest screws and extra parts, and packs more power into every linear foot than anything on the market today. We believe this is the best way to get the most out of your investment and your facility. Rig is a huge step forward for mining, which is good for Bitcoin. And what's good for Bitcoin is good for all of us. Thank you.
Thank you, Thomas. That was awesome. Next up, we have Perry Hoti, Solutions Architect at Proto, who's going to talk to us about hardware as infrastructure. Perry has been mining for a long time, since before ASICs and custom rigs and industrial mining were even a thing in Bitcoin mining. And before Proto, Perry was CTO of Argo Blockchain, where he set up mining facilities from scratch, including Helios, the world's largest immersion cooling facility at the time. A widely recognized advocate for Bitcoin mining, Perry is known for championing innovative and unconventional applications of mining technology, and we're very lucky to have him here with us at Proto. Perry, please join me on stage. Let's get right into it. So in all of your years as a mining operator and now building on Proto for everybody in the room, what are some of the biggest problems that customers have raised and that you've seen firsthand?
I mean, it's funny, the problems they've raised and they've been raising for like 10 years, it's been reliability, upgrade cycles, quality of components, and all that leads to downtime and then lost profitability. And so when we were looking at designing Rig, the thing everyone always talked about was efficiency. And of course, efficiency is one of the most important metric out there. But if you zoom out, what you're really talking about is profitability. And so when we factor in, how many fans you have to replace, how long does it take, the power supplies and everything else, upgrade cycles, how does that impact it? And so one of our design principles was, efficiency is easy to digest, it's easy to understand. But when we look at through the lens of profitability as a total, what does that really mean? And I think that's basically the thinking behind it and how this thing came to be.
When he's talking about this internally, one of the phrases that I've heard him use quite commonly is rig as infrastructure. Could you tell everyone what that means?
So if we think about it, in a mining facility, you've got transformers, network switches. That's not something you'd want to replace over and over. You'll spend the money to buy quality components. When you think of a miner, you've got the chassis, the power supply, the hash boards. Sometimes you've got a new model that has the exact same chassis, the same power supply, the same fan, but you're replacing all of it. And if you have to do that, you're not going to use high quality components. The fans are going to fail eventually because you're replacing them in a year anyways. So if we thought of it as infrastructure, we can use better components, which means the failure rate will be less on the shelf, so you have better uptime. We can design in a way where it's easier to replace, it's more modular. And again, it all comes down to profitability. When you're upgrading, the hash board should be the only thing. The power supply doesn't have to change, the control board doesn't have to change. And so when we say infrastructure, we kind of loop into that same category as the rest of the stuff in the facility.
You mentioned upgrade cycles, and I think many people in the room have been through quite a few of those. Can you talk me through one in gory detail?
Yeah. I mean, anyone who's done it, it's a combination of excitement and trepidation. Excitement because you've got brand new machines, but knowing that you're going to have to take those old ones off, you have to unpack, there's a lot of foam, cardboard, you have to get rid of all that stuff. What do you do with it? And then think of all the downtime. These are heavy machines. You've got guys on lifts, taking them down, unplugging them, blocking off hot aisles. It's a long process. And at thousands of machines, again, it all comes down to profitability. And then you've got to do something with those older ones when you're all done.
So I've heard from some customers that during upgrade cycles, miners might even move machines between physical facilities. You talk a little bit about how that happens, or why that happens, rather, and maybe how rig is different?
So I guess the term used in the industry is a lift and shift. And when you've got multiple facilities, they don't always have the same power cost. The ones with the lowest cost is where you want to run your newest machine, so they're always running. And when you have to move these older ones, you're not going to keep all that foam and packaging around. So usually they end up on a pallet, a piece of cardboard in between, and you shrink wrap. Put them in a truck, drive them across, and they break. They're not meant to be transported that way, but it happens. And so you think about all of the logistics, the ops, then the repair, for something that shouldn't really have to, you shouldn't have to do all those things. All that's being replaced in reality is the hashboards. But all that other stuff is just something that unfortunately is the way it's been done and has to get done. And one thing we thought of, there's got to be a better way. And I think that's what we can see with Rig.
Could you show us?
Absolutely. So, anyone who's taken apart a miner, this is it. You take your fans off, you've got your power supply here, and that's the hashboard. These are all the components in less than 10 seconds. The nice thing is you can upgrade basically at your own pace. So if you're running basically a two-board system because you've got really low-cost power, you can actually leave this blank, and that's what we've shown here. So we include this baffle, so we make sure the airflow goes exactly where it's supposed to. Come upgrade time, you can take this out and put in your generation board in. So you could run basically 2 older generation, a third one, or put the same. And what we want to make sure is you can spend exactly what you need to get the efficiency for that profitability that you need. Nothing here takes more than really 5 seconds. I know we say 90, but you can do it a lot faster.
I'm really looking forward to everybody in the audience getting to play with the hardware back there right afterwards as well. Something Thomas mentioned earlier was that Rig can help with stranded power. Could you talk about how that works?
So, what we mean when we say stranded power is miners build facilities, and you're always thinking in dollars per megawatt. It cost me X, $200,000, $300,000, $400,000 per megawatt. So then okay, it cost me X amount per plug. If it's 4K, 4,000 watts per plug, well, you've got a machine that when you buy it, it consumes 3,500 watts. Over time, difficulty goes up, hash price comes down, the machine's not as profitable. Maybe you have to downclock. So let's say that same machine now you're running at 2,600 watts, maybe 2,200 watts. That's anywhere between a third and 25% of power that you're not using that you spent a lot of money to build out. Which means, over time, that machine now, in that facility, you've lost, 30% of your power that you paid for that's not being utilized. So with a Rig, the nice thing is you can still downclock and get more efficient, but then you can slip another board in, right? That middle, you can take that baffle out, put another board, whether it's the same generation, whether it's in your generation, and you're not replacing the whole thing, right? It's just what you need when you need it, and you're still utilizing all the power that you built.
I think what he's highlighting helps underscore how Rig will drop right into a lot of different infrastructure, but knowing that there are so many different sites and so many different requirements, even represented by individual miners in the room. One question that I want to add on here is, if folks look through the tech specs of Rig and 9 out of 10 of them are perfect, but they kind of wish one was slightly different, what would you tell them?
So we actually have someone in the audience that exact problem, and they asked us about it. They built really nice immersion facilities, bespoke power per plug for that, and their choice would be to basically rip out their tanks or redo their PDUs, none of which are cheap. But this is modular. We can easily take out that power supply and replace it with something that has a little more power that suits their needs. Now, this is not something we're going to do, for a few, but usually miners buy more than one machine. And this way, once this is in, they never have to change their infrastructure again. The power is being utilized, the tanks are still being utilized, and they can just change the hashboards whenever it's time.
Before we wrap up this segment, anything else you want to add?
I guess the only other thing I would say is, having been on the other side of this for a long time, one of the reasons I joined Block was to see, could we make better hardware? And the longer I've been here, the more I've realized there are some amazing people here, hardware, software, operations, and all of it had to come together to put this thing together. And so I'm really glad, and I think anyone who tries it, uses it, swaps out a board, will realize the work those people have put in.
Thanks, Perry. And since you mentioned the great team behind Proto, we're going to bring two more of them up here. While we're getting set up, I'd like to introduce Mike Lamfalussy and Dora Engebretson, who are going to come up and talk about hardware and systems design. The two of them have helped build cell phones, payment systems, and other hardware devices that have been used by hundreds of millions of people worldwide. Dora leads hardware operations and has been at Block for 11 years, starting on Square before moving over to Bitcoin hardware. Her team handles the supply chain, from component sourcing to manufacturing, logistics, and planning. Her background is in manufacturing and process quality engineering, and before Block, she was at Apple, 3M, and worked on solar panel manufacturing. Mike leads hardware engineering and has been at Block for more than 12 years, initially on Square and now on Bitcoin hardware. His team includes electrical, mechanical, manufacturing test engineering, program management, firmware, and even the silicon validation team for our custom mining chips. Mike's background is in electrical engineering and engineering program management, and before Block, he was at Apple and Motorola, working on the iPhone and other cell phone hardware. Their teams have extremely deep roots, building incredible technology coming from Apple, Amazon, Google, Tesla, a long list of companies who help redirect and ultimately revolutionize industries. Dora and Mike, please join me on stage. Before we dive in and talk about Proto, I actually want to start before that. I'd love to talk a little bit about your work at Apple and on Square, and really curious, how does designing consumer products translate to building mining rigs?
Yeah. Fundamentally, it's really the same. Whether you have merchants using Square payments terminals, or you have Bitcoin operators running mining rigs, all of that is not that different. We're always starting with the customer and making sure that all the hardware, whichever it is meeting the customer needs. So you have a bunch of engineering work that we do that equally translates from one to the other as well. So whether it's either one, we are always making sure that our extensive test plans, our extensive reliability testing, our thermal testing, all of that translates over between the two. Always making sure that we meet the customer needs.
Yeah, another thing I want to emphasize is scale. It's very different to build one or 100 of something as it is to build 1 million of something. And I think that's an area where our team really shines. A couple examples, if you guys remember COVID, manufacturing sites got shut down. There were a lot of logistics challenges. And then kind of immediately following that was the chip shortage, which shut down some industries. It's hard to find cars, washing machines, kind of anything that had technology in it. But during that time, Square managed to stay in stock, and I think it really speaks to the team's ability to kind of plan, look around corners, pivot. We made a lot of changes at that time, and just a lot of risk management that kind of came into play during that time. So that's, one of the areas I think is really important when we think about mining.
Remember that well, and I think there was an incredible amount of complexity hidden by her team during that time. Let's fast forward. I want to talk about Proto.
Yep.
Let's talk about how the rig story starts. So how do we get from like a back-of-the-envelope drawing and a concept and an idea like that to where we are now?
Yeah. You just kind of start with the obvious answer, which was to look at what's out there, maybe make something very similar, our own version of it. But as we started hiring more and more people who were familiar with Bitcoin mining, talked to a bunch of operators, folks like yourselves, technicians, people who deploy and maintain these, it started to change a bit. It was Perry, who spoke before, who was the one who suggested changing the form factor around a little bit. He had suggested trying to improve the density, and that's how we ended up with kind of 3 machines worth of power into the space of 2 legacy machines. So once we land there, we start to look at some more nuanced parts of the design. So what else can we improve? It's one thing to just change the form factor around. What else can we do to make this better for people who maintain and operate these machines? Well, basically, you realize that when you have to change a lot of parts, there's a few things that often frequently fail, get replaced. So why not make it more modular? So that's where we kind of came up with the concept of hash boards you can slide in and out, power supplies you can slide in and out. Make those changes really easy. So once you land on that, it started to feel like it was really the product that we needed to make. So at that point, we knew we were onto something, and that's how we landed at this.
You mentioned reliability, and so I'd love to hear more about when you get into the deep into the design phase. How do you prevent things from breaking?
Sure. Well, we do lots of design, lots of simulation up front. We basically want to put these machines in all extremes of their operating conditions. You want to see what fails first, find the weak points, and then we iterate and fix those things and continue to make sure we get to the point where they're able to be pushed through all extremes and still function. So one example I'll point to when we were designing Proto Rig, we were putting it in the accelerated life testing, exposing it to heat, humidity, corrosion factors, and of course, lo and behold, some of the parts of the housing start to corrode, parts of the chassis. So to help solve that, we decided to powder coat it. So that really makes sense, obviously not just from a longevity perspective and reliability perspective, but as Perry was talking about the chassis as infrastructure, it really starts to make sense to spend that money, make something that's durable, make something that lasts, that you can reuse through upgrade cycles. So at that point, I would say it also doesn't hurt that it looks pretty nice, I think.
Yeah, I love that that level of attention to detail is what surfaces problems then, not later. And the tricky thing is, even once we've gotten to that point, there's still yet another feat to make sure that, even if we fix it in design and we think it's going to work for 1 or 100 systems, I'd love to hear from Dora on how do we make sure that the 10,000th and 100,000th and beyond are exactly the same.
Yeah, definitely want to emphasize the level of depth that the team goes into. We don't just look at how does this rig come together at our manufacturing site and what does it look like at the end. We're really looking through this whole supply chain. What does each component supplier, what does their process look like? What does their outgoing quality checks look like? Then again, when we bring it into the manufacturing site, we're testing every rig throughout manufacturing, again, before we ship it. And, just again, can't emphasize the amount of depth. And we've got people who are on site kind of auditing, checking, managing everything all along the way. So yeah, definitely not just during development. I think the one example I'd share to kind of highlight that for our power supply, our engineering and operations teams, we worked hand in hand with our supplier on a custom design. So during development, we came up with their validation plan for how do we make sure that that power supply is meeting our expectations. But then even after we started production, we kind of maintained that same level of rigor. And one example, we continued with 24-hour burn-in for our power supply into production. And
I would say, in case of you don't know what burn-in is, so we basically will exercise the hardware, put it through some very early thermal cycling, get it hot, get it cold, and that can sometimes cause, if there's any weak hardware that's out there, it can basically help force early failures by testing it a little bit. And by forcing those failures, weed out any issues, make sure they don't land at the customer.
Yeah, and only after finding no failures after we scaled did we start kind of peeling back. So yeah, I think we kind of go the extra mile to make sure nothing breaks.
Yeah. So even when we go that extra mile, I think every single person in this room knows that no matter how much we put in the design phase, it does not mean 0 field failures. Like, stuff is going to break. It's just never the case that there's 0. And so I want to transition to talk a little bit about what happens when we do start to see some field failures. How do we react? What do we learn? What do we bring back? How do we fix it?
Sure. Yeah, we know things are going to break. We can get over our own egos there. We know that despite our best efforts that things are going to fail. But to deal with that early on, we have a process we call early field failure analysis, or EFFA. So the purpose of that is to basically anything that ends up in a customer's hands that fails, we immediately work to get that hardware back, do failure analysis, find out what happened. Is it a material issue? Is it a process issue in the factory? Is it, worst case, a design issue that we have to do something about? At that point, we would go back to the vendors. If it's material, put in screens, do extra checks, screen that material coming out, screen it again coming into our factory. If it's process issues, work with Dora's team in the factory, make sure all the operating procedures for assembling the hardware in the first place are being followed exactly as they should be. If something's missed, address it there. And again, worst case scenario, design issue where basically at that point, getting the rest of my engineering team involved and figuring out what we have to change in the design to help prevent the failure from happening again.
So when we get to the point where we believe we know how we're going to prevent the failure from happening again, we still have to take action to make that true in manufacturing and on the line. Dora, could you talk about how that works?
Yeah, I'd actually maybe start with an example. In our first sample shipment of rig, we actually found that one of them got dented during shipment, and we're not okay with that. So same day we found out that there was an issue, formed the team, and we immediately started kind of redesigning our pallets and reevaluating our packaging to make sure that it didn't happen again. And I think that's just a good example to show we're committed to making sure that what shows up is good. There's a couple other things I'd highlight. One of them is traceability. Through the whole supply chain, we're tracking key components. So we know the key components that went into every rig. If we do find an issue, we know how to contain it, identify it, and fix it. The other one is replacement parts. So one example I'd reference for Square, we manage hundreds of SKUs. We have overnight warranty shipment replacements. And we're bringing that same DNA to rig. We have the supply chain set up to do that. And so, if you need a new fan or if you need a new power supply, you should be able to get one fast.
Yeah. And should be able to get one that's a genuine replacement part, not having to go to third-party solutions to find ways to keep your machines running. Just we want to make sure that everyone can always get the parts they need to keep them running.
We're going to move on to talking about software in just a moment, but before we do, I'd love to close this segment out by asking you, Dora, to talk a little bit about how all of this comes together from a supply chain perspective.
Yeah, really can't overstate kind of the deep connections we have through the supply chain. And it may not be obvious at a surface level, but we've been able to leverage a lot of the supply chain we built over the years on the Square side for rig. So those are connections and relationships we've had for many, many years. So that's really helped us kind of stand this up quickly. We also partner with global tier 1 suppliers, which gives us a lot of flexibility in terms of manufacturing location, including the US. And that's an area we're very, very focused on. And it's also an area we have a lot of experience in. We built BitKey in the US. Some of us have experience in prior companies, and we've done our early builds for rig in the US, and we're continuing to invest heavily in scaling that out.
I'm totally biased, but it's amazing to me what goes into building reliable systems and delivering them at scale. So thank you both for taking us through.
Great.
Yeah,
Thank you.
Thank you.
And now, last but not least, I want to bring up Brian Stiegel, who leads software design for Proto, to talk a little bit about Proto Fleet. Brian has been a leader in product design across industries for 20 years. On the agency side, he has done work for Google, Nike, Yahoo, eBay, and many household brands. Brian has been at Block since 2016, led design for Square for many years, and has additionally led design for Tidal and several of our Bitcoin initiatives. Please welcome Brian.
All right, thank you, Max, and thank you all for coming out here today to join us for this event. I'd like to spend some time talking about the problems we set out to solve when we were designing Proto Fleet. So we chatted with a ton of different people in varying sizes of operations, and we listened to all the complaints, all the criticisms, what's going well, what's not, and we broke that down into 3 areas that we wanted to focus on when we were designing our software. 1, that there's too many tools. 2, making it simple is important, and automation and AI is the 3rd one. And we're going to hit each one of these one by one. So first up, let's talk about too many tools. We saw different tools for provisioning and setting up your miners, curtailment, monitoring repairs. having all these tools doesn't really help with training your employees, and we wanted to really focus on getting all of this stuff into one place with one familiar UI so that it's easy to do across everything you're trying to do. So we wanted to start there with just like getting your miners into the system. So we saw many methods for doing this as well. Typically starts with an IP scraper, a third-party IP scraper, where you're getting information about your miners, then you're plugging that into a spreadsheet, which is another different thing, and then you're uploading a CSV from that spreadsheet into another piece of software to basically just get all of your miners into your system. So we want to just get rid of all of that and do all of it in one place. So we built an IP scraper directly into Proto Fleet, which then reconciles the miners and puts them right into your system. This paired with, we already know all the stock usernames and passwords for all the top miners on the market, so we'll just go ahead and try and authenticate those automatically for you, so you don't have to even bother with plugging those in. So what that really means is you can get thousands of miners set up in a matter of minutes with one tool really quickly. So we're also rethinking how you build floor plans and map out your facility. We saw many different ways and different tools that people were doing this as well. Once again, often involving a spreadsheet. So with that, we make it super easy for you to build that floor plan and your rack configuration right in the software. And then taking that a step further, you can go out onto the floor and you can just scan a QR code or a MAC address that's on the physical machine and put that right into the spot that you put in your software. So you may have seen a phone on the last screen. Something that made me personally shed a tear every time I was talking to many of you was how many times I saw people zipping around and zooming into desktop optimized software while you're out on location trying to troubleshoot problems or fix things. So that was a really important thing for us to make sure that out of the box, Proto Fleet is mobile optimized, so it works on the device that you're using right when you need it. So let's move on to our next theme that we were focused on of making it simple. Most of the software that we saw wasn't particularly user-friendly. Typically, you had to dig around through a lot of different menus to find the information you were looking for. The information was often surfaced as API calls instead of plain language. And these are the types of problems that we are very equipped to deal with after designing software at Square for many years that requires little to no training for thousands of people all over the world. So we wanted to focus first on the dashboard itself. So we wanted to make clean and clear dashboards with robust, easy to read information that gives you pretty much the whole picture you need on one screen. And the other thing we wanted to focus on is surfacing alerts and information when you need it. So if there's something you should see, it should be right there on the first screen you look at. You shouldn't have to dig around through many different menus trying to find the answer to the problem that you're looking for. And then next, I want to talk about errors and troubleshooting. Pretty much everybody I spoke to said they wish that you would just tell us what the problem is instead of surface an error code that then you need to go figure out what the problem actually is. So that's exactly what we did. If fan 3 is broken, we tell you fan 3 is broken. If hashboard 5 is broken, we tell you hashboard 5 is broken. It's a simple concept, I know, but apparently it does not exist. And then to take that even further, we wanted to mirror this error communication on Proto Rigs as well. So like if you see here, well, actually it's not, oh, there it is. If you see here, we have the LED display on the Proto Rig, which shows the same iconography and the same error language that shows up in the software. So if you see that there's a problem on the software, once you're out on the floor, you can quickly confirm that that is the thing you're looking for and fix the problems even faster. So to take that an even step further of easiness, we're providing robust repair guides right in Proto Fleet from the error screens. So here's an example here where if you were to click on something and there was a broken hashboard, you can pop this open, you get a step-by-step guide of all the things you need to do to fix that, along with a list of tools you need and a list of spare parts that you would also need so that your team can go right out on the floor and confidently fix things and have everything they need. So now let's talk about the third area that we really wanted to focus on, and that is automation and AI. So we believe that mining software should have the same quality experience and functionality that you're getting in the best consumer-grade software that you're used to using every single day. And that's the kind of efficiency gains that you get through powerful automation and AI-driven alerts. These are the things that can help you get ahead of problems before they even occur. So to start, we want to introduce a modern AI-powered AI chat-powered interface. So instead of having to fish around through the software and figure out what the problem actually is, you can just ask what the problem is, and we will surface all kinds of charts and data that gives you everything you need to know to answer the questions and optimize your whole operation. This is also important to us because it streamlines the training of staff once again, and it also saves time troubleshooting problems. And then we don't want to stop at the chat interface. We want to go a step further there, too. We want to provide automated alerts so that you don't even have to ask the chat interface. So things like suggesting when you need to order new fans when your supply is low, or scheduling to throttle your power based off of the weather conditions or abnormal spikes in electricity, or even spotting problems and then assigning technicians out of the gate to get your operation up and running again. But we're not going to stop there either. Like, that's cool too, but we want to make it even smarter. So with that, we want to build in smart automations and presets so your fleet can just run on autopilot and you set it and forget it. Proto Fleet will integrate with live energy costs, Bitcoin prices, weather conditions, and miner temperatures, and automatically adjust your fleet based off of whatever conditions you want. But it goes even further than that. Fleet will also combine with broader data of your facility so that you can get a better picture of your energy costs throughout your whole operation and not just your miners. So I want to also talk about some features that aren't specific to Proto Fleet, but there are other features of our software. So Proto Rigs will support Stratum v2 out of the box. It's a more efficient protocol that offers that offers native hash rate auditing, which helps detect and reduce issues like miner misconfiguration, unwanted diversions, and other fleet-wide issues. Also, Proto Fleet comes out of the box with secure boot technology to guarantee that the firmware you're running comes from Proto. This is an extra measure that prevents supply chain attacks, malware attacks, and theft of Bitcoin rewards. We'll also allow you to disable secure boot technology easily if you want to do something of your own. And as Thomas had mentioned, Proto Fleet is open source. So if you want to fork it and build your own, you can do that. And who knows, maybe one of you will build the next awesome feature that just benefits the whole community for everybody. And then, as great as all that sounds, if you don't want to use Proto Fleet, you don't have to. We have robust APIs and documentation that will be available so you can integrate with whatever software you choose. And then lastly, as Thomas also mentioned, this is all free. So anybody can use this. Anybody can take advantage of this software. So that all sounds cool, but that's actually just the beginning of where we're going with the software. We're looking forward to continuing to be in touch with customers and talk to you all to figure out how we can make this better moving forward for everybody. And we'll be releasing Proto Fleet today in a closed beta. So if you're here at the event, you can track one of us down, and we can tell you how to get access. Otherwise, later on today, you'll be able to go to our website at proto.xyz and sign up to get access to the closed beta. Now, let's take a quick look at a video that recaps everything you've seen today before Max comes up to close us off. Thank you.
Thanks, Brian. And that's a wrap for our live stream. So thanks to everybody tuning in with Bitcoin Magazine. And if you want to learn more about Proto, head to proto.xyz and get in touch.